Hello, so we have this figure here, and it says two blocks are connected over a pulley. The mass of block A is 11 kilograms, and the coefficient of kinetic friction between A and the incline is 0.21. And angle theta, which is represented by nothing, but now it's going to be theta. So this theta is 30 degrees. Okay. So block A slides down the incline at a constant speed. So what is the mass of block B? Okay, so it's asking for the mass of this block B, and it says this thing slides down at constant speed, which means this and this is equal. So let's draw a free body diagram for this real quick. So we have our mass A. We have our mass A. So for mass A, we have our this, of course. This one is mg sine cosine, my bad, mg cosine of 30, and we have this one, which is mg sine of 30. Also, we have the normal force, and this is just going to equal normal force, because there's no other forces except for gravity that's having effect on this one. So this is going to be normal force of N, and we have our force of friction because this is moving this way. So we're gonna say this is positive this time. So this is going to be positive. So let me draw it over here too. So this is going to be positive. So which means friction is going opposite direction. So this is going to be friction. So this is going to be friction. So this is kinetic friction. Kinetic friction. And what else do we have? We also have tension going at this way. So tension. Do we have anything else? I don't think so. So let's move on to B. Well, B has, okay, let's say this is MA. Let's distinguish this. So this is mass A, mass of A, and this is mass of A as well. It's important that we distinguish this. Okay. And then we have this one, this B body, and this is going to be mass of B times gravity, and it also has tension, but this is going to be positive, and this is going to be negative, because we have to look at the diagram. So this is going to be positive. So if you go this way, then it's negative. So this is negative, and this is negative. This is positive, and this tension is positive. Okay. So let me label it. So that's negative, and this is negative. All right. So we have our free body diagram. Okay. So it says the block A slides down the incline at constant speed. This means that this force over here and these forces over here cancel out. So they if you combine these, they equal 0. So let's write that down. So let's write that down. So mass of A times G times sine of 30 minus T minus f of k. Okay, let me before we do that, let's define f of k. Well, the force of kinetic frictions on the side. Okay, so let's take, okay, hang on. Okay, so force of kinetic is actually mu of kinetic times mu being the constant, the kinetic friction constant, or mu being the friction constant, and this is kinetic, times the normal force, force of N. So this is equal to, the constant is given here. So it says coefficient of kinetic friction. So that's the coefficient of kinetic friction, and it says it's 0.21. So 0.21, and it's different for you, and the mass of block A is different for you too. So yeah, this might be different, like mass of A. So times the normal force. So normal force is just gonna be ma, the mass of A times G times cosine of 30. Cosine of 30. So that is gonna be our equation there. So we're gonna bring this over here. We're gonna bring this right over here. So let's just cut this. Let's just cut this out and then just plug it in there. So I'm just gonna move this up here, so you can just reference it. All right. So we have our equation here, and this is gonna equal to 0. This is gonna equal to 0. Yeah. So this is the just to make the colors be the same, I'm just gonna say that this is equal to this. The colors are the same, so reflexive property. Okay. So now we add this to each side. So we get what do we get? We get mass of A times G times sine of 30. Sine of 30 is equal to, if we add T and 0.21 this thing to each side, we get T plus, well, I don't think, okay, let's not add T. Let's just let's not add this one. Let's just keep it there. So I'm just gonna keep this one. I'm only gonna solve for T. So I'm gonna do that. I'm just gonna solve for T and see what happens. It's good to have a value. So let me bring up my calculator here. I have to start my calculator, and here's my calculator, and let's do this. So let me actually write this down. So mass of A is 11 kilograms. Okay, so 11 times gravity, which is 9.8 times sine of 30, minus 0.21 times mass, oh, this is 9.8, not mine. Okay, so mass of A, which is 11 times gravity, which is 9.8, times cosine of 30. So that's going to be our tension. So T is equal to, let's calculate that using our calculator. So 11 times 9.8 times sine of 30 minus 0.21 times 11 times 9.8 times cosine of 30. So let's see what that gives us. That gives us 34.3. So I'm going to store that into T for tension. So 34.3. Tension is 34.3. All right. So since the tension is 34.3, we know that this is 34.3, and since block A slides down the incline at constant speed, we know that block B is also going up at constant speed, like this way, positively. So basically what this means is that since it's constant speed, acceleration is 0, which means the force that's acting on the net force is 0, which means T is actually equal to mb over mb times g. So T, so let me write that down. So T, this is the second one. So this is second one, and T equals mb, which is mass of B times g. And we know T, which is this, and we know G, which is 9.8. So 34.3 is equal to mb over mb times g, or mb times 9.8. So the mass of B is, let's see, 30. This divided by 9.8. So let's see what we get. We got 3.5. So we got 3.5 kilograms of mass. Okay, so let's plug this into our WebAssign and see if it's right. Okay, so we have 3.5. and it is correct. So I hope this helps you with this problem, and yeah, thank you.